At dawn in the desert, a nervous physicist wondered if one spark would set the sky on fire. The plan was simple in theory and terrifying in reality. Make a tiny sun in the sands of New Mexico, then pray the blast ends itself before the atmosphere decides to join in. This moment matters because it did not just end a war. It rewired power, fear, and possibility for the entire planet. The path to that dawn was jagged, brilliant, and haunted. J. Robert Oppenheimer was not built to be ordinary. He could mesmerize a room, slice through problems across physics, chemistry, and engineering, and yet he carried a storm inside. At 21, he left a poisoned apple on a tutor's desk, a desperate act from a young man drowning under expectations, clumsy in the lab, and enthralled by ideas he could not stop chasing. He escaped the misery of the basement benches by diving into the new language of the universe. Quantum mechanics was roaring to life, and in Göttingen under Max Born, he found his tribe. The halls pulsed with names that would define a century. Heisenberg, Pauli, Dirac, von Neumann. Here, theory was king, and Oppenheimer was finally a prince who belonged. He wrote quickly, argued fiercely, and saw connections faster than most could write them down. But no one there knew how those minds would collide years later on opposite sides of a race no one dared imagine. At the time, giants scoffed at the dream of atomic power. Split an atom on command and harvest energy from it? Moonshine, said the old guard. Then came the neutral guest at the nuclear party. The neutron, uncharged, unwilling to be pushed away by a positive nucleus. If a way existed to coax a nucleus into splitting, neutrons could be the key. One idea lit the fuse in a quiet mind. If one split could release more neutrons than it consumed, then matter could fall into a chain reaction. Find the right element, the right balance, and a cascade would begin. That theory waited for a spark. It arrived in 1939 with a newspaper in a barber shop. A young physicist read that uranium had been split by neutrons. He ran, half-shorn, to show the skeptic with the booming brain. The first reaction was disbelief. The second, within minutes, was calculation and acceptance. If fission is real, it can release energy on a scale that turns battles into ash and cities into memory. Word of the possibility reached the highest office. Committees formed, then dragged their feet. War accelerated everything. The uranium work shifted from a curiosity to a race. That race needed a builder. The military chose a general with iron instincts. He picked a scientist who did not look like a commander. Thin, intense, politically suspect with no Nobel Prize and no practice running industrial armies. The choice was controversial. It was also perfect. Oppenheimer could speak every language the project required, even if he never sat long enough to tally every calculation. He proposed a place that lived in his memory like a second love. A mesa in New Mexico, isolated, beautiful, and safe enough if the unknown went badly. He underestimated everything except the pressure. The scale exploded. Hundreds of scientists, thousands of workers, entire towns fed a secret city on a hill. Meanwhile, the first human-made chain reaction flickered to life under a football stadium. It whispered a promise. If a pile could run, a bomb could roar. Making it roar depended on a simple, brutal truth. Pack enough fissile material together fast enough, and neutrons will find new homes. That critical mass is a moving target, shaped by density, reflectors, and timing. Early designs were straightforward in concept. RAM2 subcritical, lumps together like a bullet and a target. Uranium was the fuel, but it hid inside ore like gold dust scattered in a riverbed. The fraction that actually fissions is tiny. So machines the size of buildings would have to separate the right atoms from the wrong ones, feeding a war with the invisible. Even the small problems felt enormous. How do you keep metal sliding perfectly in the millisecond that decides everything? Oils failed under the violence of the blast. The solution came from the ocean. a strange reminder that every device leans on nature in ways that feel improbable. Then came the pivot. Plutonium, born from uranium in reactors, offered a darker gift. It needed less material to reach the threshold, but it also refused to wait. A gun would misfire. The chain reaction would start too soon, and the bomb would cough instead of scream. Compression solved it. Wrap explosive lenses around a core and slam it inward evenly. Raise density, drop critical mass, ignite the heart. But even that heart needed a spark. A tiny pellet sat inside, beryllium and polonium kept apart until shock married them. Alpha particles would kick neutrons free, and those neutrons would ask the core a single question. Will you run? While the engineers carved a sphere and the chemists tamed new elements, a rumor circled the labs like a storm dog. What if the explosion did not stop where it started? Hydrogen floats in the air, water drifts as vapor, nitrogen fills most of the sky. At the right heat and pressure, fusion could wake up. Once awake, could the atmosphere become fuel? The probability looked small. The image looked enormous. A world wrapped in fire. Many dismissed it. A few carried it like a stone. The day was set anyway. A device on a tower, scientists in bunkers, a clock that refused to slow. The count reached 0. Conventional charges crushed the core. The initiator did its job. A blue-white light carved a scar in the sky. The shock rolled out like a tidal wave of air. Sand turned to green glass. The mountains glowed as if the sun had fallen close. The atmosphere did not catch. The world's first nuclear test had spoken, and it was louder than anyone imagined. Weeks later, 2 cities learned what that voice meant. A gun-type device over Hiroshima, an implosion device over Nagasaki. The yields were numbers. The reality was people. The tally of the dead rose in hours, then in months, from blast, burns, and the invisible bite of radiation. War ended. Awe and dread replaced disbelief. With victory came a new argument. Build something worse, or lock the gate behind the weapon just made. The next chapter burned hotter. A layered bomb where a fission burst acts like a match for fusion fuel. One test turned entire atolls into memory. Another in a distant sea dwarfed it again. A demonstration of power so vast, it felt more like geology than warfare. The maker who led the first effort argued to slow down, to hold back, to choose control over escalation. The nation chose speed. Cameras watched. Wiretaps listened. Accusations cut deep. Trials turned public. Reputation became a battlefield. In the end, the clearance vanished, but not the complexity. Oppenheimer was never only an architect of destruction or only a cautionary voice. He was both, a paradox standing at the hinge of history. The list that leads to that desert morning is a chain reaction itself. A troubled student, a city of ideas, a barber's newspaper, a general's gamble, a metal sphere with a secret spark, a fear about the sky, a flash that ended one war and began another. When a civilization learns to light stars on Earth, what debt does it owe to the future that must live with that fire?